Good morning again, dear students. تقبل this is another video to solve another problem was requested by one of the students, and this is a vector-based problem. So pay attention to how I solve this one because it's a little bit complicated, and I'm gonna go about every step with a little bit of detail so you can understand what's gonna happen. In this problem, as we're gonna study, we're gonna read the question. The question is like this. It said that this is a drawing where the OA vector is representing a value of 8a. So we're gonna sketch a little bit here. OA is actually representing 8a. Okay. Also saying that OB is representing 6b. So 6b is gonna be for this side here, OB. Also saying that M is the point on OB. M is the point on OB such that OM to the ratio of OM to MB is 1 to 2. What is the idea? It means that OM has a ratio of 1 out of 3 and this one has a ratio of 2 out of 3. So when I try to describe it, don't forget that this is 6b, right? So what's the third? The third, this is representing this one, here representing third of 6b. It means that's going to be equal to what? It's going to be equal to, this is a third of 6b, so it's going to be 2b. So this is going to be, I'm going to use a different coding. This is going to be 2b. And since this is 2b, it means that this is going to be 4b. So keep that in mind. Also saying that N is the midpoint on AB. This point here is splitting the AB into two equal sides. So if we said that this part is equal to x, this is going to be equal to x. Also saying that P is the point of intersection of ON and AM. This is the headache in this question. The headache is actually that this line that you see here, which is the MA, and this line that is called ON or NO, these are intersected lines inside of a shape, our shape, which is they are very difficult to extract or to express when you're dealing with vectors. When you're dealing with outer lines of a triangle, it's easy, but right now it's telling you one thing, that these two lines, they intersect at the point P. Okay, now using the vector method, find out OP. So the idea that we want, the question is about finding the value of OP, and he wants the OP vector as simple as possible in terms of A and B. So the first thing that you need to understand, that if you remember, we said that we refer to two terminologies. There's something called scalar. If you remember, I'm going to express something here. If this is equal to n, and this line here is actually 2n, if this is going to be bigger than them, it's going to be 3n. 3 here, 2, whatever you want to name it, this we refer to this as scalar. Okay. Another thing that I need you to understand, if I have a line like this as OP, and this line has another line here where this is PN, these two lines, we call them, we say that they are collinear with each other. Okay, so the terminology of scalar and collinear is clear to you now. Now let's get to work with this question. The first thing that you need to understand, that you have to express the OP in certain ways. Okay, so when I look at this triangle that I see in front of you, I can describe two things that they have the OP shape. First of all, I can describe OP as part of the big line here, the big line that you see here. Okay, so I can say that the ON as a vector, this is the first thing, ON vector is a total of two lines, right? It's the total of OP vector, because this is a collinear, and the Pn. This is the first thing. Also, I can describe OP as also in a, this is, we say that this is the collinear way. Also, I can describe the OP as a scalar out of the ON, right? I can say that OP vector is representing what? Representing x of the vector ON. It's a ratio, an amount. So OP is a fixed amount equal to x of ON. You got the idea? Because this is the same idea. And OP is actually representing a scalar multiplied by ON. So this is the scalar form of OP. And we're going to call it, this equation, we're going to call it equation 1 because we're going to use it in the next steps regarding this problem. Now, if I look at the shape again, and I want to look at the other intersected line, this one, the MA. The MA, if I want to describe it as, I want to describe it in a way where this whole line is multiplied by a value to express a part of the line. So what I'm trying to tell you that you can look at this because we can use this, the vector AP. How I can show the vector AP here? The vector AP is actually equal to a scalar, and I'm going to refer to the other scalar as y here, so we don't get confused with the x. X is the scalar value of the OP, while y is the scalar for the AP. So AP is equal to y AM. It's the same concept of the previous equation, but here we are trying to apply it on the, we are trying to express the two intersected points in a scalar way, because this is the only way that we can solve this problem. Now, the second part about what you can do. Now let's get back to the OP. The OP, I know that it's equal to XON, but look at the shape now. I'm gonna remove a few lines here so you don't get confused. I'm gonna keep the outer information. So look at the OP. When I try to look to it from the point of view where we have this triangle, let's say that I wanted to express the ON, okay? Because here I know that OP is equal to what? OP vector is equal to my scalar value x multiplied in ON. I wanted to look to ON as part of this triangle. If you look to it from this point of view, if I say that ON, okay, look at the direction, this is ON, right? So ON is actually representing the vector of OA plus the vector of AN, right? This is a way of looking at the vector from this triangle of this shape. So now I can open a bracket. I can express the ON vector in a shape of what? Of OA vector plus the AN vector. Now this is part of how you can solve this problem. Again, now I'm gonna do something about this part here. I'm gonna do something about the AN here. AN, when you look to it, when you look at the AN, I remember that it's representing what? If you remember the previous, it's actually representing a value. N is the midpoint, where, so it makes that the AN and its length is equal to NB. So basically, the AN from this discussion, AN vector, could be the half, could be described as the half of AB. Clear? So it means that the OP as a vector is equal to my scalar value, and I'm trying to keeping all the different coding of colors, so you pay attention with me. Multiplied in what? Multiplied in OA vector plus what? Not an anymore. I'm gonna replace the an with the vector ab, but is equal to half. Sorry, I forgot to add the half. Plus half ab vector. Okay. Now the idea that I'm gonna try to reshape this equation into something that can reduct the OA. What is the meaning of this? Look at this shape here. I mean, look at the AB when I talk about the vector of AB. I'm gonna remove the sketching here, so pay attention to me. This is the whole of AB, right? I can draw AB in terms of a bigger triangle, right? I can say that this triangle AB is the result of this vector beside this vector. So I'm looking to the largest triangle in my shape. So the AB could be equal to a resulted AB as a vector could be equal to minus OA, if you understand what I'm doing. I can write it as AO, but I don't need that because it's gonna be useless. I need it to be in the same order of this other term. So it's gonna be minus OA plus the OB. I hope that this is clear to you. So now this form is going to be converted in the following. So my OP vector now is going to be equal to what? Equal to the x scalar multiplied in what? OA vector plus half. But half of what? We said AB. AB here is equal to what? Half of OB minus OB minus OA. Clear? Why I'm doing this? I need these two terms here. They are in the same order because when I subtract, when I'm gonna reduct, I can get rid, I can simplify my equation. So now the OP vector is gonna be equal to what? It's gonna be equal to x multiplied in what? Multiplied in OA vector plus what? Plus half OB vector. I'm gonna expand the half in this bracket. So it's gonna be plus half OB minus half OA vector. Now what I'm gonna do, I'm gonna get rid of these two like terms. So the OP vector, I'm gonna write here now. So the OP vector is gonna be equal to what? It's gonna be equal to x multiplied in what? Multiplied in, remember you have OA minus OA, OA minus half OA. So what's gonna be left is half OA vector plus half the OB vector. Now I can collect like terms, I can factorize. So factorizing is gonna make me have this equation in this form. The OP is gonna be equal to what? I can factorize the half that you see here. So I can get it out of the bracket. So it becomes what here? This is gonna be x over 2 multiplied in what? Multiplied in OA vector plus the OB vector. Okay, so that is how you can represent this fraction, and you can say that, I mean, you can keep it as this form or you can change it into this form. It's the same thing, because later what you're gonna do is that you're gonna try to equalize everything. So this form is gonna be equal to what? It's gonna be equal to x over 2 multiplied in OA vector plus x over 2 multiplied in OB vector. And this is gonna be equation number 3, because these are very important equations. Okay, this is B. Now I'm gonna get back to what? Now pay attention. Everything that I was doing right now was considering this equation. I was doing everything considering this equation. Now I'm gonna pay attention to this equation. I'm gonna try explain how I can convert the AP into something. We're gonna do the same operation to the AP. So now pay attention to what I'm gonna do, because this is equation number 3. Now I'm gonna bring my equation that I was describing, but before that I have to explain something. Look at the shape that we have here. I'm gonna go back to erasing few lines here so you can pay attention with me. Look at the OP vector. If you remember, we said that the OP, I can represent the OP using the lower triangle by saying that the OP is equal to OA plus the AP. What is the meaning of it? I say that I can represent this as what? I can say that the OP equal to what? Equal to OA plus the AP. You got the idea? So now I'm gonna explain. I'm gonna write it down here. I'm gonna try to split this so you don't get lost. The OP now can be described in another way. I say that it's gonna be equal to OA plus the AP vector. Okay. Now the idea is that I can convert the AP vector here the same way that we say that it's gonna be equal. I can say that the AP is equal to y multiplied in AM. So the OP now, so I'm gonna use the white color. The OP vector is gonna be equal to OA vector plus what? Plus y multiplied in AM vector. Clear? Now let's try to convert. We're gonna do the same thing for the AM vector as we did in the previous equation. This is equal to OA plus, of course it's gonna be y here, but the AM is the idea that we're gonna do a trick with. Now look at the AM. I need you to look at this triangle now. I need you to build a relation and pay attention. Now I'm gonna erase this. Where's my AM? AM is this vector, and AM is part of this vector here, the AO, and again I'm gonna say minus OA plus the OM. So I'm dealing with this triangle, as you can see. So now the OP is going to be equal to OA plus y multiplied in what? AM is going to be converted. AM is going to be equal to the OM vector minus the OA vector, as I showed you here. Remember? So you don't get lost. This is the OM vector. Okay, because I'm talking about AM here. So it's going to be equal to OM. AM is going to be equal to the minus OA plus the OM, because this is how we go. AM is equal to this vector plus this vector. So this vector is going to be equal to what? It's actually equal to minus OA, which is the same as saying AO, but I don't care about AO because I need to keep the order. I'm dealing with this vector as OA in this order, plus what? Plus this vector that you see here. So you don't wonder what is the meaning of OM. Okay, the direction OM. So now we reach this form of equation, which is the second equation. This is the second representation of OP. Now, what I can do as well, I can say that OP is equal to OA plus Y multiplied in what? I have OM and OA. The same thing. I'm gonna look the OM as from another perspective. Now look at the OM here. I'm gonna erase a few things so you can pay attention to me. Now look at the OM here. If you remember when we talked about the ratio, the OM, if you remember, we said it's representing 2B out of the 6B, right? So I can express OM as a 2B, right? So I'm gonna get back here. I'm gonna say that before that, I'm gonna expand the bracket. This is Y multiplied in OM vector minus what? Minus Y multiplied in the OA vector. I don't need brackets anymore. Now I'm gonna do the same thing that I did earlier, but for that I have to factorize what you see in front of you. Here you have OA, here you have the OA, so you need to factorize these two. So you're gonna take Y and you're gonna take 1 minus Y as an outer bracket. So OP is gonna be equal to what? It's gonna be equal to 1 minus Y multiplied in what? 1 minus Y multiplied in the vector of OA vector plus Y multiplied in the OM vector. I hope this is clear to you. Now I'm gonna get to that point when I mentioned that the OM can be described as 2B. So the OP vector is actually equal to 1 minus Y multiplied in OA. I'm gonna change the coding so you don't get confused. Multiplied, come on. Okay, it's the same glitch. I'm gonna fix it just a second. So OA vector plus what? Plus Y multiplied in what? Y? The OM. We said that the OM can be described as what? The OM. The OM representing what? I'm not gonna use it to be OM. Look at the OM. OM is representing 2B, but the same thing, I needed to understand that this 2B is actually the third of what? The whole thing. So it's the third of OB. This is the form that I need right now. So Y is going to be multiplied in OM, and OM is actually nothing but the third of OB vector. Okay? Now we're going to try to make this equation a little bit organized by saying that OP is actually equal to 1 minus Y multiplied on the OA vector plus what? Plus Y over 3 OB vector. Now this is your equation number 4. Clear? Now what do I get from this? Now pay attention to this equation and this equation here. What do you notice? You need to notice that both of them look at, this is the coefficient of OA is equal to x over 2, and the coefficient of OB is equal to x over 2, and both of them, they are part of the OP, which is the same thing if you understand what I'm trying to say. So this is the coefficient of OA, this is the coefficient of OB out of OA. What is the meaning of that? It means that these two equations can tell us the following, can tell us that that the x over 2, this is the coefficient of the first equation of OA, equal to this one, equal to 1 over 1 minus x. This is equation number 5. While x over 2 as well of this part is equal to y over 3. See, now the point is that we had a new two equations that enable us to figure out what should be the value of x and y, which is part of the OP vector. Now let's get to this equation first. The x over 2 equal 1 minus y. I can try to use these two equations by saying what? Since they have this side equal to each other, I can say that y, 1 minus y, is actually equal to y over 3, right? So I will get rid of this 3 with this part, so it's gonna be equal to what? It means that y is gonna be equal to 3 minus 3y. So 3y plus y is gonna be equal to 3. It means that the 4y is gonna be equal to 3, and from this I know that y, the variable that I'm dealing with, is equal to 3 over 4. This is the first thing. Now after I figure out the value of y, I can take one of these two equations and apply it in the one of these two equations. I can take this one for example. This one saying that the x over 2 equal to what? Equal to y over 3. And I know that y is equal to 3 over 4, so it's actually equal to what? It's actually 3 over 4 divided by y, divided by 3. Clear? So the x over 2 is equal to 3 over 4 multiplied in the reciprocal, which is going to be equal to 3 over 12, which is going to be equal to 1 over 4. So x over 2 now, it means that x could be equal to quarter multiplied in 2, right? So it's going to be 2 over 4, which means that it's going to be equal to half. So it means that x, the other variable that I was looking of its value, is equal to half. Clear? Now we're going to use these two variables to make up with the previous equations, if you remember the value of OP. Now I'm gonna write down these equations again. The first equation is equal, we're saying that the OP is equal to x over 2 of OA vector plus the x over 2 of over 2 of the OB vector, right? So I'm gonna change the value of x. It's a straightforward process now. So the OP vector is equal to what? The x is equal to half. So when I try to describe this, it's an x over 2. So it's going to be equal to what? It's a half divided by 2, which is equal to half multiplied by the reciprocal of 2, which is going to be half. So it's going to be equal to quarter. So the OP is going to be equal to what? Quarter of OA vector plus quarter of OB vector. Okay. Now that's the form that we reached now, right? So we are saying that the OP is actually representing the quarter of OA and the quarter of OB. Now the last step to solve this problem, look at the equation. I'm going to clear everything because it's not needed. So how I describe the OA is representing what? It's an 8A, right? And the OB is representing the 6B. So we're going to take these values. And we will say that OP is equal to the quarter of what? OA. We said that OA is equal to what? The OA is equal to 8A. 8a plus quarter multiplied in OB, and the OB is equal to what? Equal to 6b. So the OP vector is equal to half, and this is 2. It goes with the 8, is going to be 4. So this is going to be equal to 4a plus, this is 4, this is go 2, with the 3 is going to be 3, so it's going to be plus 3 over 2b. And to correct this is not going to be the, actually this is a quarter, sorry, now this is a quarter, not a half. So when you cancel 4 with the 8, it's going to be 2, it's not going to be 4. So this point here is going to be actually 2a. So this is representing my solution, the OP vector, which is, as he asked the question, was written in terms of a and b. So OP vector is going to be equal to 2a plus 2a plus 3 over 2b. That is the solution. I hope that it was clear for you. This problem is not an easy one, it's a very hard one, but I hope that this video is explaining how you can reach the final solution step by step. See you in other videos, and good luck with your exams, guys.